very much. I just want to give you a quick overview of where we are with Agrement Certification and the number of applications. I think people are a bit confused that I'm just looking after Irish companies, but I have loads of global companies that are involved with us in certification. And I was even meeting a delegation yesterday of mass engineered timber, European companies coming into here into Ireland. I also want to show you some of the different material types and technologies that were coming into us as well, and just to show you the breadth and depth of it. I also want to share my secret sauce, 6M plus I and C. This is how I've used over the last 30 years of delivering projects, and it applies to any single project you're ever going to use, and I challenge you today to take it away and apply it to your factories or your on-site applications. I just want to touch upon some of the documentation and the challenges we're having around that in terms of the Agrement certification, and then give you some examples of what we're seeing on the sites or in the factories in terms of quality control. So if I just move in on the updates, we have to go back to technical guidance document part D. That is where NSAI is referenced in Agrement certification. There is no European, there is no global standard for MMC. Yes, the BSI published the PAS 8700, but it's only for residential construction and it's only a publicly available standard. So for us to accelerate, what's happening is rules and regulations are trying to catch up with the advancement and innovation that's happening in the modern metals construction space. It's for any new or innovative building materials or systems or processes, and that's where Agrement comes into place. We were mentioned in the programme for government. We're here to support that, and we're to bridge the gap because there is no CE marking standard for MMC, and it's only for products. But we're looking at the whole building systems, all 67 building elements, the walls, the doors, the frames, and we're also looking at the interfaces. So like what the previous speaker showed you, the connections, the points of connection, the interfaces, they're the challenges for us. And then there is a European technical assessment, but that is like a visa. It's only a visa to place the product on a European market. It's not your passport to install, because you have to look at the different climatic conditions, the different locations that are in. So we have radon, but we don't have seismic activities that the Italians have. We have the storm Elwyn that we had recently. They don't have that on mainland Europe in some cases. So you've got to adapt your systems to the area and climatic and local conditions, and that's set out in TGD Part D. You then can have an Irish standard. We only have IS 440. There is a 3D concrete printing standard, but it's an ISO ASTM standard, and it's only general principles. So it doesn't cover all 3D concrete printing applications. And then you've got the Irish Agrement certification, which is to bridge the gap where there is no standards and regulations that I talked about. But looking at the different companies, and what I want you to look at here is very carefully. I haven't named the companies, but you can see the date of application and the material type in the second column. I also want you to look at the notes. So we have 7 stages within the Agrement certification process, and a lot of them are in technical review, but some don't come back to me. No correspondence since September 2024, no correspondence 2024. We constantly reach out to these organizations. They've made an application, they've paid a fee. In some cases, they've signed a contract with us, but there's no movement. And I can't make the move or can't move forward with them. We have other examples here then of where they're at gap analysis stage. You can see the different types of steel frame, structured, welded steel, light gauge steel. Some have even confirmed what building system or technology they're going to use yet. You start to see ICF, mass engineered timber, structural insulated panels, precast, sandwich panels. So you're starting to see a good range here. Then some withdraw their applications or some want to put it on hold. We will have a kick-off meeting with them. We will work with the off-site manufacturers as best we can. There's different ones that have moved to gap analysis, and for us, we want them to get the factory production control stage. This is where we're validating all their documentation, all their design, all the good stuff that they say they have. We want to verify that both in the factory and on site, and that's where the challenge starts coming into play. But you can see where they're at, hot rolled steel. It's predominantly very much welded steel frame systems, and then there's some people that are just pending their application. So it takes about 6 to 9 months from them making an initial inquiry to NSAI before they come into us and start the process. Then we do a gap analysis initially on what they submit, and then it takes another 3 months before they start giving us a really detailed technical pack and we sign up a contract with them. So this is the challenges that we're starting to see out there. And for us, the summary is we want them to engage with us. Keep reaching out to us, reach to our team. We're available, we can contactable. A lot of people have my name and number. They call me, whatever. We're happy to keep that process going. We're here to work with you. We were set up in the NSAI Act 1996. We're also in our NSAI strategy to support SME, and we're in the programme for governments to improve MMC certification. So that's what we're here for. What we're also seeing is only 3D volumetric systems have only started in the last 12 months. That's where it's starting to come into it. It's predominantly 2D panelized systems. And what we see is when we get the factory production control stage, we're at stage 5 or 7. That's a real positive stage. That's when we know the factories are getting ready and they're going to be getting close to certification. And then we're looking at the welded steel frames is predominantly what we're seeing, although there's some mass engineered timber starting to make its presence here, possibly due to sustainability targets. This is myself visiting a factory over in Poland. That's the size of the module, 16 tons, not even cladded. When it's finished, it's going to be 30 tons. That was going to a hotel, and this is courtesy of our client. And you can see the size and everything that we have to look at. This is looking down at the factory. This is one half of it, and there was 4 of them. And you can see all the modules laid up all the way down the side and the guys working away in the crew. This is some of the email comments I get back when I reach out to off-site manufacturers. Apologies, Martin, I'm working through the list that you gave me. I'm engaging with our clients and we hope to get back to you soon. Martin, thanks for reaching out. Thanks for your voicemail. Thanks for your question, but we're not in a position to actively push forward with Agrement certification. However, can we keep our submission on hold? This is the type of stuff we want to work with off-site managers, we want to work with them, but I can't move if they're not going to move forward. So it's a two-way street. You've got to come forward and present your documentation and we'll move forward with you. What people always say is Agrement not a one price or one fixed contract. No, it's not. It's based on the different purpose groups. It's based on the different heights of the buildings. It's also based on the material technology and types. It's also based on the scale of the operation. So therefore, it can't be a one size fits all. It's not a one size fixed price, fixed term contract. We need to scope that out with the various offsite manufacturers, and then that will determine the length and depth of the certification process and technical assessment we have to carry out. This is the 6 M's plus I and C's. So I'll explain what that is now in a minute, but I first want to talk about what is quality. This is a definition that holds true from 1978, and it still holds true to this day. It's the totality of features and characteristics of a product or service that bears on its ability to satisfy stated and implied needs. Very chunky, but I'll break it down for you. What it is everything you do, the end-to-end process from this. It's no different to farm to fork, it's factory to site. It's the product that they're manufacturing, it's the ability, but it's not just the specifications, drawings, engineering, design. It is the legislation, the regulations, the standards, European directives, and the CE marking. It's everything to do with that, and the building regulations that we talked about earlier. Then you look at quality assurance, quality control. Everyone gets mixed up on this. So the first one was quality management system and approach, but this is a definition from ISO 9000. It is an action or framework directed before the assurance, and quality control, as I always look at it, is materials and workmanship, both off-site and on-site, and how you control that. And it's inspection and testing of those samples. So you're taking a sample of that in the inspection process. How that looks is we're providing a quality assurance scheme that is relied on you as the certifiers, the regulators, the warranty providers, the insurers, and the regulator, the building control. And that's where it comes in. But the B-car is only on a project-by-project basis. So an example I give you, B-car is not going to go to a factory in China. Are you going to travel over to China to look at some of our clients? Are you going to go to America? Are you going to go to Poland? Great if you are. But who's going to do the off-site inspections? Who's going to verify that? Who's going to validate all that documentation? We get huge packs. They're over 10,000 pages on documentation. I'm happy to give it out to anyone here for them to digest and review technically, or you can rely on the Agrement certification to do that for you and support that. And that's what we hopefully rely on, and we want to work with people on that. And then I always use this definition. This is from Dr. Peter Love and Hang Lee. They've written over 400 construction journals. He's in Australia and Hang Lee is in Hong Kong. Design errors and omissions are the primary cause of rework and construction. And that is proven in multiple papers that they've published. And that's what we're trying to avoid. However, when you start into multiple sectors, you start bringing in additional regulatory requirements. So we have the TGDs Part A to M, but then you start going into design manual for quality housing. There's this new standardized approach that Construct Innovate are doing and looking at different acceptable details for the likes of light gauge steel or other ICF for different connections, but you have the schools designs guides. So an offsite manufacturer in the residential sector cannot just pivot into the educational sector just like that. There's a whole series of other requirements and regulations. No different as you start moving up to the data center, the biopharmaceuticals, and then you have the healthcare, HTM standards that was on the National Children's Hospital. So it's not like for like here. So this is where people start telling me it's like Lego and it's nice and simple. There's a lot more variables to this than just what I'm trying to show you. I'm trying to show you the length and breadth of this and how detailed it is. For me, quality is a function of the people, the process, the technology, leadership, or more simply, quality is expectations minus reality. What are you actually getting for your off-site manufacturing, and what is in reality is arriving on site and is fit for purpose and in use. So what I always do is 6M plus INC. I look at the materials. I look at the methods that they're employing, both on-site and off-site. I'm looking at the manpower, the competency of both the design team, the professionals and the trades. I'm looking at the equipment, the tools. Is it calibrated? Is it verified? I look at the measurement, and what I mean by that is inspection, testing, quality control records, the checks and balances. And I'm looking at how the weathering, the protection, and how that product will interact. Is it UV rated? Is it going to degrade over time? That durability that we talk about. So, and then I look at continuously improving that process, and then how we communicate that. So that's my 6Ms plus INC. It's project neutral, it's material neutral, it's sector neutral. I've applied this for the last 30 years on all the projects I've ever worked on, and it works out perfectly. And I challenge you to try that to your projects and your processes. I'm looking at the specifications. I'm looking at the storing, the weathering, protection of it. Over, short, and damaged. Does the module arrive? Has it got something too much on it? Is it missing something? Is there poor interconnection? Whereas the interfaces, and I'll show you some examples of how this has happened. Even though we have 3D modeling, this should not happen. Everything should be documented and detailed. Has it got the CE marking? Has it got the declaration of performances? And are they checking it? And is it fit for the essential characteristics? We're also looking at the contract scope of works. Has there been any variations and changes? Looking at the models, looking at requests for information, technical queries, and we're keen on the standard operating procedures. It's the offsite manufacturer's processes. We're not here to challenge and question that, but we want to see it. We want the evidence, we want to see the validation, we want to see the verification of that. And trust me, I'll go into full detail on this. And I want to see it in the PIPs and the INFs. I want to see offsite manufacturing captured in that and the stages of inspection. Where is that? And is it there? I do see it in some of it. I'm looking at the qualifications. And what we mean by qualifications is in TGD, the definition, are they competent? Competent are things. Qualifications, knowledge, experience, and skill. That's what we're looking for. It's a combination of all them. The problem with experience and skill is modern methods of construction is new. So we all have to upscale. We all have to get more knowledgeable around this. And I'm learning every day. And then it's taking pride and ownership in that. But it's also having the right tools to do the job. So we're looking at the torquing, the bolting, the assembly, the points of connection. That's when a modular is going to fail, at the interfaces. If you look at any of the reports over in the UK, it's at the interfaces. It's where things come together. We're looking at as the equipment that you're using is calibrated, the gauges, and they're all in working order. And then finally, we're looking at the quality control checklist, the test packs, the evidence that verifies or validates. And that's the track and trace and the thing. I don't mind if it's pen and paper. I don't mind if it's digital. I don't mind if it's on an app. But what we do is we go into the factory and they tell us all about these wonderful checks. We get to the end of the process and we start seeing errors in the modules and things. And I said, but you just told me we just go through 100% checks. And yet we see gaps and errors in the process and the system. And then Mother Nature. Be very careful. Program affects how people operate. When you start putting things under pressure, people perform differently. So it's the environment, the culture, and that's why factory production control lends itself. Factory off-site, it's a nice controlled environment as opposed to on-site, chaotic, multiple trades. But you're also looking at the weather, the temperature, and that's why off-site manufacturing lends itself to drive improved productivity, and that's been proven in numerous reports. And where this all comes from is the fishbone diagram. Root cause analysis. Ishikawa, it's been around since 1980, and every time I had a quality problem, one of those ingredients was always missing, one or more. So if you go back to look at any of your problems or any issues you've ever had on a project or site or in a factory, one of those ingredients, and you can drill down to it. Don't look at the symptoms, look at the root cause of the problem and drill into it and then try to prevent it. And what I do is the reverse of that. So it's nothing new or novel or innovative. It's very simple. What you're trying to do is get into a nice zone of control. You're taking out these sporadic spikes, these unknowns or unvariables, and you're driving, you're driving that quality improvement. But what's key is you've got the lessons learned, the feedback loops. So the best organizations are feeding that back from the offsite activities, back into their production, back into their crews, and they're constantly improving. And you'll see that with the offsite manufacturers. I see a maturity level with a lot of these companies. Some are really good and innovative, and others are quite stagnant and slow and don't take those feedback loops and learn on the process. Just touch upon some of the documentation that we're starting to see out there and the issues. So we're looking at everything, the durability, the thermal, the structure of fire, not just the TGDs A to M. We're looking, as I said, the competency of the people, the test results, the calculations, the quality control manuals, the installation manuals, and the maintenance around that. Because just when the module's finished and installed on site, we want to see how it's maintained post-production and post-occupancy. So just be careful of that. My 3 challenges. This is the slide I want you to take away from today. Documentation. It doesn't always match what it says in the tin. The amount of times I get pieces of paper, out-of-date documents, documents that don't match the essential characteristics. I challenge you all to look at this documentation. Look at the devil in the detail. Look at the European Technical Assessment. What does it cover? What doesn't it cover? What's in the manufacturer's instructions? What's in the literature? Factory production control, 80–90% of where it is. So when we go to the factory, it's not bad. It's getting better. It's improving. But we still start seeing errors out there. We see some very basic checks that weren't done or carried out. Small attention to detail. And that shouldn't be happening on the production floor and using the right jigs. But they are improving. The on-site is not where it needs to be. It is not at the standard or level. It's like a curbside delivery. They drop the modules in or drop the 2D panelized systems and a different team or different crew takes it over. The control around that and the interfaces with the various trades is not there. I don't see it as strongly as controlled as it would be in the factory, and it's an area that we need to look on. We need to look at the points of connection, even the mechanical and electrical, how that interfaces with the module. I've seen them compromising some of the modules. It was my fear, and that's what I'm starting to see on the sites now. So I will be pushing in on that, and I will be doing unannounced visits on some sites. We have a readiness scorecard to help organisations. It's very freely available. It's a self-assessment. It's against the TGD's Part A to M, and then it's also against factory production control readiness. So again, and then we score it against what the off-site manufacturers provide to us. And it gives you a nice radar diagram and it tells you where your gaps and all that are. And then just to wrap up, I just want to show you some of the recent images that we've seen. We see some good stuff with light gauge steel. We can see the material traceability. We can see the mill certs, and we can see the material. We can also see that they weather the products better. So really good companies are weathering their modules now, and that's what Mario talked about, the weathering of moisture. Moisture is going to be your biggest trouble here with these modules and getting exposed to the climatic conditions here. This is a weld. We'd gone to a factory and we asked them what inspection levels they do, 100% visual and 10% non-destructive testing. The white paint is magnetic particle inspection. It's a form of NDT. That was for the other welds, and this is the quality of the weld I got. And this is another site with ICF. But then I see some really good stuff in the factory where they were doing the rendering, putting on the mesh, putting on the base coat, and they can see that they're doing the posi joists in the correct orientation on the ICF. So they can do some good stuff. It's that education and training and knowledge piece that I talk about with the checks and balances. So just to wrap up then in summary, for me, it's about looking at these 6 key elements. If you are doing any inspections or audits or assigned cert or design cert roles, do go to the factories. Do apply this methodology, and I'm telling you, it'll work really well for you and always continuously improve. So thank you very much.